Okay, we are hearing you well and we are able to see your screen, and the conversation is being recorded. Please go ahead.
Thank you. So I'm going to talk about file handling and also pickling. Most of the time we have our files, and as we have our files, we use them to save documents or to transfer documents from one person to another. And so as we work with Python, we may ask ourselves that then how do we create files and handle files so that our code sends information to some files somewhere that we can use to transfer that information maybe to somebody else. So that is what we want to learn about today and understand vividly how this can be done. First, I'll start with the type of files, and I will show you most that you know. In Windows, we have image files. These are files that contain images. We have text files, we have executable files, we have audio files, some files contain videos, so we have video files, etc., etc. But we are talking about Python, then we just have text files and binary files. Anything that is text is saved as a text file. Otherwise, anything else is going into a file as binary. And in the past, we have talked about binary, zeros and ones. So that is how Python refer anything that is not text. So when we are talking about file handling, what are the things that we can do within file handling methods? We talk of CRUD. Some people call it CRUD. I'll call it CRUD. So the operations that we can do in file we refer as CRUD, meaning creating file, reading from a file that you have created, updating a file, like you can write into that file and you add more data into that file. You can delete some things, you can delete some information. So basically we talk of updating a file and then we call deletion. So we are creating a file, reading a file, updating a file and delete a file, and that we are all going to see tonight. The key function for working with files in Python is the open function. So as we're going to learn about this, there is a key function that we cannot do without. This function is referred as open function. With open function, we can create a file, we can open a file. So we create a file if it does not exist. We open a file, we work in a file. So working in a file means we can read from it, write to it, and even add more text to it. We can delete it, we can also close it. So these are basically the things that we can do when we are working with file. So as I've said that open function is a very key function in Python. The open function has got two main parameters that we must know. The first one is file name. So once you say open and then the opening and closing normal brackets, you give the file name as an argument and you give the mode. So the mode is the mode that you are opening the file for. For instance, if I'm opening a file to read, then the mode is read. If I'm opening a file to write, then the mode is write. If I'm opening a file to create, then the mode is create, right? So the syntax that is, you just say open, file name, and then the mode, and we are going to see that. When we are using open function, we can also use a statement referred as with. with. So we can use with statement in Python such that we don't have to close the file handler. Every time we just say open a file, then we have to close it. Otherwise, it will remain open. But if we use the with function, then this with function comes with a close handler. We don't have to close that file. The with statement creates a context manager, and it will automatically close the file handler for you when you are done with it. Here is an example of using a with statement to read all lines of a file. So we would go like with open, and then you give the file name, the mode. So this R can change depending on the mode. And then as, if I say as FH, then it means that the object file I'm creating will be called FH. And then I read all the lines, and I'm going to see you how basically the reading takes place in my next slides. The key functions for working with file in Python, we have said is open, and we have also said that we can open a file in different modes. So remember, when you say open, you give a file name and then you give the mode. A file name is any name that you want. If you want to your file to maybe be called just file, then it will be file. If you want any name that you want, just like the way you normally do your files. And then mode is different modes for opening a file. So R is read. If you want to open a file in the read form mode, then you just put R in quotes. It is the default value. It opens a file for reading. And if the file does not exist, then you get an error telling you that that file does not exist. So read will only be possible if the file that you want to read from is in existence. We also have A or A, it's append. It opens a file for appending. And if that file does not exist, then it will create it. So we can use A to also create. It opens a file for appending and creates it if it doesn't exist. So if it doesn't exist, you don't get an error. W is write mode. It opens a file for writing, creates the file if file does not exist. Then we have X, which is create. Create the specified file, returns an error if the file exists. So when you use X, then it must be that that file is not there. It is not existing. If the file is there, it will give you an error. In addition, you can specify if the file should be handled as binary or text. So if you use T, that is text, and mostly text is the default value, so you don't need to put it. But B is not default. So if you want to open a file to write or read in binary, then you have to use the B because it is the binary mode, e.g. the images that I've talked about, the audios, the videos, and the rest, which are not text. Other file, okay, basically to explain this more, I will just go through this fast. R opens file in read-only mode, while the file offset is at the root. Then we have RB, which opens in binary and read. So if I say RB, then I mean it will be opening it for reading in binary. And then R plus is read and write. So if you put R plus, then it means you're opening it to read and you can also write. RB plus, read, write, and it is binary. Then W, we have said, is write. one thing you need to remember about W is that if you open a file in a W mode, then anything you write overrides what was originally available in that file. So if that file was already there and with some content, if you use W, then it will override the content that was originally in that file. We have WB, which is now write in binary, W plus, which is read and write. W plus, read, write, binary. Then A, I've explained, it's to append. So that's what now helps you, so that if your file already has content, you don't delete that content, you just add to what is already in that file. So you use append, and append mostly will append at the end of the line, the last line, the last statement. So it begins at the end of it. And then we have AB, which append binary, A plus append and also allows to read, and then AB plus append read binary. So those are things that basically you really have to remember as we are handling these. So let's talk about read. We have said already that read is the default. So if you want to open a file for reading, you can either say, so F is the object name, the file name. So I say F equals open demofile.txt. If I write it like this, like open demofile.txt, then it will open it in the read mode. I can still say open demofile.txt read. So demofile.txt is the file name, and then read is the mode that I'm opening it to. Reading text file in Python. So we use the file.read. File is any name that you're giving object. So we are going to see that. There are lots of ways to read a text file in Python. You can decide that you want to read all the characters, all the content, everything that is within that file. You can also decide that you want to just read some characters, not everything. You can decide that I just want to read the first 5 characters, or I just want to read like 20 characters. So you decide and you put that in your code so that it gives you exactly how much or what to what extent you want to read. So we go like file equals open text file.txt and then read mode, and then because we are reading, we print. You remember print? So when we are reading, we print it so that it reads for us and displays for us on the IDE where we are working. So you say print file dot read. The object I created is file, so I file dot read. It depends with what name you gave to your object. We can read just like the first 5 characters, the first 3 characters. So you would write like print file.read in bracket 5. So this will allow you just to print the first 5 characters, that file. You can also just say print file.read, and this now gives you everything. You can decide to read line by line. So it's line by line output. If I say print file.read line, then it will be reading the first line. If I say print file.read line 3, that will make it to read only the third line, only the third line. So other lines will not be considered. It will only print for me the third line that I requested for. If we print file.readLines, so read lines will give me all the lines and they will be nicely separated the way we are going to see when we get to our code. So mark those because I'll also show them practically. For a fast and efficient way to read lines, we can loop. You remember the last Zoom meeting, we were talking about loops. We were talking about for loop, while loop. So we can loop so that we are able to read fast and efficiently. So you will write it like for line in file. For line in file, print file dot read line. And if you leave it like this, then it will clearly read all the lines. It will be looping. Remember the way we explained the for loop. It takes from the beginning of an object to the end of the object. So it will read line by line until the whole of that file is, the whole of the content of that file is completely printed out for you. Now let's talk about the write method. Writing to an existing file. To write to an existing file, you must add a parameter to the open function. So if we say append, it will append to the end of the file, and that I've explained. If we just say write, it will overwrite an existing file. So that's where now we bring this important warning, a warning. Note, the W method will overwrite the entire file. So if you're working with a file that you had already worked on and saved, then you come and you just like open your file in W mode, then anything you write will make sure that the original content will go, and then you will only have what you have added, which is new. So watch out when you're using the write, know exactly why you're using it so that you don't lose the content. Otherwise, use append if you don't want to overwrite. So the method is, or the syntax, I create an object F, so you can call it anything, equals to open, and then I'm creating it in the documents folder. You can put it at the desktop, on any disk, local disk C, D, or flash disk, wherever you want, you get the path clean. So open documents, and I am calling it demo file.txt in the write read mode. After I open it in the write read mode, then I can now start writing. For me to now write, I call the object F that I had created up there, dot write. Now the file has new content. So this content will go into that file. And the next thing that you do that is very important, you close it. If you want to append, you do the same thing. After you have appended, you close it. So remember, if you don't use the with, then you have to close. File write method, we have talked about it. So it is file, and then you open in the write mode. You can decide to put several lines. So this is the test, to add more lines, and then you close it. So allow me to go to my VS Code so that I show you a few of what we have talked about. Sorry, trying to minimize that. Okay, it is done. Okay, so so I'm showing this in the VS Code. Most of the time when I've been teaching, I've been using Google Colab. Today, I decided to use this so that I store my files at my local computer. Remember, Google Colab is on the cloud. So if you're creating files, you create them on the cloud, and unless you download them, they remain on the cloud. So I'm using this so that I create files on my local machine. So the first thing I've done is to import OS. I will explain how important that is in my next slides. And then I am saying file, open documents, demo.txt on a write mode. And then I'm writing the word hello world, and then I'm closing. So the best thing to do now is to first of all check if that exists. So those who have been using Windows, you know, if you search it from here, from the type search, you will be able to see it if it is existing. So I just want to ensure that you all see that we want to create it and create it in the right mode. So basically, we don't have a demo. What is showing here is demo file, not demo.txt. So if I run this code, I'm expecting that now I have created a demo file, which has now come, and in it, I have hello world. So I have hello world, I close it, and I want to add more text. So before I add more text, allow me just to remove hello world. So I say greetings class. So let me see what happens. Remember, my file has hello world. So if I run this, and then I open my demo file, just to show, my hello world that was already inside here is completely overwritten. So I have greetings class. It is gone. If I do a different thing again, I say, I love Python. And I also add file dot write. So I say, and I love this class, right? So I run it. I open my file. I find I love Python and I love this class. So now I don't want to overwrite that. I want to append. I want to append. So allow me to make whatever I'm appending a break. So I'll use that. That makes it to print the new one on the next line so that it is not the same line. So this will not be necessary, but I can have one here. So let me run it. Open my demo file. Good. So I love Python and I love this class. I love Python and I love this class. So you see the original one remains and the next ones have been appended to it. I now want to read. I want to read all that. So allow me to change this so that we don't have so many things appended. I want to read all that in my IDE. So I'll also clear this. So when I'm reading, I am file open documents demo.txt and I'm reading, then file read line. Remember now this is read line. So I want you to mark that as well. If I run this, I only display, the only that one that is displayed for me is I love Python. Why? Because I told it to read line. If I change this and put 5 and run it, it gives I love, and that love is not even complete. Why? It is speaking the first 5 characters. So I, the free space, and then the love, 5 characters. If I add 6, sure, it will give me my love in full. I love, so it brings that in full. So let me say I want to read the lines, not line. So now it separates them with the /n. I love Python and I love this class. So all of them come and they are separated nicely so that you're able to see how it is working. So you'll be able to see that. What if I want to delete? I want to delete this file. That takes me back to the slides so that we talk about other things before we delete. So we've seen how we have created files. We have talked about creating using X, and we are saying this will create a file and returns an error. If it does not exist, append and W. Those we have talked about, the 3 ways that we can use to create a file. We can also use the with. So instead of saying file equals open text file.txt in the X mode, or txt in the W mode, I can say with open txt.file X as file. So now this file comes here as file, and then it is with open. So that is something that you need also to know. When we want to delete a file, the first thing we need to know is that we need an OS. So we call an OS function. Library. So we import OS. To delete a file, you must import the OS module and run its os.remove, because that is the module or the function that is going to clean or to delete for you your file.
Okay, Lucy.
Yes?
So we need to let people know what is OS. OS stands for operating system.
Oh, I thought I said it in full at some point. Okay. So OS simply means the operating system. So from it, we have a function called remove. So this remove is what is going to delete for you the file that you want to delete. So if you import operating system and then you use the os.remove function, then you give in the name of your file. The first thing again that you also need to remember is that when you're deleting a file, you need to check if it is existing. You can't delete it if it doesn't exist. So it is proper that you use the decision-making structure. You remember we talked about if, else, and the rest. So you will say import OS. If os.path.exist, then you give the name of your file. If it is in a path, then you show the old path the way I've shown in my previous slides. And then os.remove, then you remove that file. Else, print the file does not exist. Very important. So it will tell you that the file is already deleted. If you want to delete a folder, then you will import OS library, and then you will use this function os dot remove directory. So directory is like a folder. So os dot rmdir, that is remove directory, and then you give the name of the folder, and that will work for you. Let's see how that works. Remember, I've checked, our demo file is there, right? So we just want to delete it. So let me comment this out. Because we don't need it, but then we need this one that is going to help us in the deleting. Import OS if os.path.exist. So the path is documents and then demo.txt, os.remove, and then else print file does not exist. So allow me to clear my terminal again so that we see it clearly. If I run this code, the first time it shows me this. I don't know whether it found the file, it deleted the file, or whichever. If I run it again, it tells me the file does not exist. Well, so it means my file is gone. So I can check. And indeed, my demo file is no more. Remember again that you don't have to create your files direct from here. You can literally like open maybe a notepad, create a file, give it a name. So let me save as demo.txt. Even if I don't say .txt, that is the extension. And I want to put it on the desktop. So let me put it on the desktop and save it. So let me just confirm that it is on the desktop. Here it is. I can open it and maybe say something inside it directly. So hello world. I save the new content and then I just close it. I get to my Python IDE. So with this, the only thing I need to change is it is no longer documents, it is desktop. So let me make sure that I'm not having errors, so I'll remove that. And I don't want to delete it, so I'll also, sorry for that, 1, 2, 3. So I'm just commenting this out. So remember, we are writing into it. If it does not exist, we create it, but right now we have it, desktop. So it is desktop. So it is existing. If I run this, you see it has it. I love Python and I love this class. So it has gone to desktop. It has added the new and deleted the original one. I love Python and I love this class. So you can basically write from a file that you have not just started creating if it was existing, and that is the way to go. Good. Other methods that you can use include closes an open file. We've talked about that. Touch, file now, flash, and all these. They are in the notes that George gave us, so you can read about them and practice on them during your free time, so that we don't have to go like showing exactly all this, but you can practice with them because now you know exactly how you can go about it. So the next thing I want to talk about is pickle module. Python pickle module is used for serializing and deserializing a Python.
Lucy,
Yes,
did you talk about the open with?
yes, I did.
Okay, cool. Okay, all right.
I didn't show the example.
Thank you. Okay.
Yeah.
I was away. Okay, go ahead.
So Python pickle module is used for serializing and deserializing a Python object structure. Any object in Python can pickle so that it can be saved on disk. What pickle does is that it serializes the object first before writing it to file. Pickling is a way to convert a Python object. So we know the Python objects. We have list, we have dictionary, we have tuple, we have files. All those are objects. So these objects, we can pickle them into a character stream. So if we have Python objects, then we pickle them, then we get the strings, and this goes like they are compressed into a way that you cannot even read them if you don't unpickle them. And we are going to talk about also unpickle. So to pickle, you say pickle.dump, it gives you the serials. You see now the serials are like in binary. If you want to get the serials back to the objects, then you use pickle.load. To pickle, pickle.dump. To unpickle, you use pickle.load. The purpose of pickling is to translate data into a format that can be transferred from RAM disk. The pickle module implements binary protocols for serializing and deserializing a Python object structure. So basically, you would ask yourself that, why do we pickle? Why exactly do we have to pickle? Most of the time when we want to transfer a Python file, for instance, I am writing a Python file and I want to transfer it through the network, maybe to Monica. Within the network, there are a lot of things that can interfere with my file. My file can be infected with viruses, if that is the right word to use. So they can get it is not safe over the network. It is never safe for the files. So if you pickle them, then you preserve them for transfer over the network to make them reach the destination as safe without viruses or without any interference. So when Monica that I was sending the file to receives my file as pickled, she will unpickle it. So it is like compressed so that she can unpickle it and have it safely. The warning therefore is the pickle module is not secure. Only unpickle data that you trust. You know the source of that data. If the data is coming from Lucy to you, you know Lucy has sent me this, so you can unpickle. But anything just coming over the net, coming to you pickled, do not attempt to unpickle because the pickle module is not secure. I hope that sinks. So we have talked about pickling, and I've said we use the dump function or method. The dump method is used to pickle any object. The syntax is dump, and then you have the object name. So the object can be your list, can be your dictionary, can be any object that you want to pickle, and then the file object, and then the protocol. So the protocol, remember, it is zeros and one. It is not necessary. so you don't have to put it. So the syntax is import OS. You have to again import operating system. Then you also have to import the pickle. You don't have to install this, so don't struggle with your IDE or with your code trying to install pickle or OS. This comes already installed, so you just import them. They are libraries that are already defined. So you just import OS, import pickle, and then now I'm defining cars. Cars it's a list, and I have Toyota, Honda, Audi, and Suzuki. Then I'm saying now, remember we talked about with. I showed you how to use it, and now we are using it. So we say with open, then cars.pkl, you can have it as cars.txt. You don't have to put it as .pkl. And then WB is now writing in binary as car pickle, and I had explained how this goes. Then you pickle.dump. So now in the pickle.dump, remember it is object and then the file name. So my file name is car pickle, and then the object is cars. So I dump. So let's go to Colab and see how this works. Good. So we have import OS, import pickle, then we have cars, Toyota, Honda, Audi, Suzuki, and then with open car.pkl, read binary mode as car pickle, pickle.dump. So I run this. When I run this, remember this is Google Colab. Google Colab is on the cloud, so you don't go to your machine to start checking. Come here, check the most left side, get this, it's called file. So if you click on it, you should be able to see the created file. So it creates on the cloud. It creates on the cloud. Good. Then the next thing after I create this is that now I want to read it. Remember my cars has this, but let me see if I read it. The way we have shown you how to read, it's the same thing. So now this is the way my Toyota, Honda, Audi, and Suzuki is being read. So this is how it is being transferred. It is pickled. So I read, and remember, when I'm pickling, I am writing in binary. When I am reading in binary. So those are things that you need to remember. Again, this is the path, and this is my file name, the cars.pkl. How did I get this? I'm saying that Google Colab is on the cloud. For you to get the path directly, you come to your file name, to your file, you click on it, you copy path, then you come and paste it here. Paste. So once you paste it, that is the path. Then you run it and you get your file pickled. It is no longer the Toyota, the Honda we had. If I want to unpickle it, then I load. Basically, if you do that, if you hover your mouse pointer over it, it gives you the reading. So during your time, you can learn all that. So in file equals open, and then I'm opening in the read binary mode. And then now my new list, I'm saying that pickle.load. So I'm loading. We had said that to pickle, you dump, to unpickle, you load, and then in file.close. So I'm using .close. I'm closing this file because I didn't use with. When I was pickling, I used with, so I didn't close. So those I think you get clearly. So if I run this, then I believe my file is back to its original state. So I have it as Toyota, Honda, Audi, and Suzuki. One thing I would also say about Colab before I wind it up is that if you are working on Colab and your file is on your local machine, you want to bring it to cloud so that you work with it. Then after you click on this that I showed you is file, you will go to this arrow showing upload. Then it takes you to your local machine. I can pick demo, open it, and bring it. So once I do that, it comes and I can now use it. I can pickle it, I can read from it, I can do anything that I want. So if you're working on Colab, make sure you bring your files there. And if you are through, you can download them. So when I download this, it will go to my downloads and I'm able to get it from my downloads. Obviously, downloads, and I have it here. So that's how we work with Colab. Those who are working with Colab, you know now that that is the way to go. You upload it, you download it to your local machine because it is on the cloud. So I've talked about unpickle. We have checked the way it is being done. It is the process of loading pickled file back to its original state. You are loading it back so that you are able to read it. We have said why we need to pickle and unpickle. And then I think that is the end of my presentation. Thank you so much.
Thank you, Lucy. Thank you very much for all the attention you guys pay. Is there anybody with a question before we go to the next presenter? Any question? Okay. All right, I'm going to go ahead and assume that we still don't have any questions. So Lucy, thank you for the good presentation. And let's go ahead and open it for Esther Wamboi.
Just one question before. When I'm using a Spider, and when I call the import OS, it's giving me an error that it's the import OS imported but not used.
Okay, so I can help you with that, but that will have to come after this, if you don't mind.
Okay.
Yeah,
Okay.
Kiprop, is that right?
Yes, yes.
Yeah. Take your screenshot and send it to me in my inbox. Then I'll take care of that for you.
Okay, thank you.
Any other question, anybody? Okay, all right. Let's go ahead and pick on Esther. Esther, run away with it. It's your turn. Regular expressions.
Yeah, we're doing regular expressions. Hi, everyone. Hope you're all doing fine. My name is Esther Wamboi, we've had, and we'll discuss regular expressions. So if you've used any text editor, or you've worked with another programming language, or you're planning to work with another programming language, you have encountered regular expressions. So what are regular expressions? These are just special characters that form patterns which enable us to search. Like they make it the pattern, using the patterns we're able to search for strings or text. And some of I just listed a few use cases that we have encountered that we need to use regular expressions. One of the most common is a search. When you're using Google, or sometimes even on WhatsApp, you're like searching for a text message, it's regular expressions. Then if you're creating an app or a system, can use regular expressions to validate the email address, the phone numbers, or the password. And then if you are planning to go into data science, be ready to use a lot of regular expressions to manipulate textual data. So regular expressions in Python, because I've mentioned a programming language, which Python is one. So we have Python supports regular expressions. And the good thing is it has a modular library that's already built in, which is known as RE, simply RE. So when you want to use regular expressions, what you do is just the same way as with the Pickle and OS, it's built in. So what we do, we need to import the RE. So I'll run this the RE cell. So in the modular library itself, it has some functions. I have listed a few of them, and I've also put a link where you can get more. So I'll explain these are the most common that you will always need to use. So we have the compile. So what the read.compile function does is that it takes the pattern itself and it makes it the expression it makes into a, like you put the expression as an object and put it into a variable. So the good thing about compiling a regular expression is that you can always reuse it. So, and I will show you an example of using the read.compile function. It comes in handy, especially if you have maybe regular expressions that you need to use over and over again, or you have many regular expressions that you need to use at once. Then we have the read.search. Read.search, it scans through the entire, like if you have a document or if you have a string, and it returns the first instance of the occurrence of the match, like the pattern, it returns the first instance. So what does that mean? And it returns a match object. Pay attention to the word a match object, because it's a very important thing. So the read.set returns a match object, and it's the first occurrence in a string. Then we have read.findAll. Is kind of the opposite of read.search, because it looks at it returns all the occurrences, but now instead of a match object, it gives us a list. The read.find iter or iter is almost similar to the read.findAll, but is different in that, yes, it returns all the occurrences, but it's not a list this time, there'll be match objects. And then instead of it will give us an iteration. So iteration means that it will go through the document, and each time it finds a match, it gives us an out. Each time is that, and we'll see that with examples. Then we have the read.sub, like sub means substitute. So what it does is that when you have it matches an occurrence of the pattern that you want, and then substitute it with another pattern that you want it to substitute. In case that is no match in what you want to be substituted, it will just return the original string that was there. And then, yeah, and also remember that with read.search and read.search, it will always return none if there's no match. The word none itself will be returned. Then we have read.split. What this does, once you put a pattern, it splits it divides maybe the string or the document into segments depending on the pattern that you have stated. Maybe if you say I want to split it wherever there is maybe I want to split it into those segments, or wherever there is certain pattern like a sentence or a word, divide it into segments. That's what read.split does. And I have put a link. What I'll do is that I'll share this notebook and can be able to access this link on the Python documentation, because there are several other methods that you might want to play around with, check them out and see, maybe you might them in your work. So now we can now go into the practical. We want to see how these regex practically work. I can just be telling you this read.search, read.whatever, but let's see how they work. So here we have a string, just created a doc string. This is called a doc string. So what a doc string is, it's just basically this entire thing is a string, but is a multi-line string, a string that has several lines. And how we do that is by using 3 quotes. These 3 single quotes indicate a doc string. So the doc string is in the variable text to start search. In this is what I'm going to do perform my regex expressions on. So we mentioned read.search. We said that read.search looks at the first occurrence of a particular pattern. So in this case, my pattern is capital ABC. Like they have to be following each other like this, ABC. And one thing you need to note is that with regular expressions, they are case sensitive. So it has to be a capital A, B, and C. So let's go in our string. We know that there's this capital ABC pattern. So we expect that definitely there'll be a match. So if I run this, I run this cell, sorry. So if I run that, we see that there's a match object. So this is what I call a match object, and it has a span and the match itself, this pattern itself. So the span is like the index. So we know that A starts at index 32 and sorry 92 and ends at index 94. So if we want to confirm that, we can check. So when we print the text to search and do the slicing of the string, if we run this, we see that it's actually ABC. Even if we were to count literally, we would just know that it will be an index 92 here. So now how do we can be with this match object, we can do a lot of stuff with match object. So one of the things is we can get the span, which we have figured out here. We have seen here, we can be able to get the span. We can also get the string. So the string returns the entire string, like it will return the entire string. You know, sometimes you might have a document which has so many strings, but in case have one string. So it definitely return this. Then we have group. Group now returns the particular string where there was a match, like the part of the string. So if where now I wanted to match ABC, so it will match ABC. And I want us to, because I want us to know that remember that ABC is regular expressions are case sensitive. So like if you look for searching for ABC, we'll notice that the span will be different. So if I run this, you see it's at 5. This is the first occurrence of the pattern here. So you notice that it's case sensitive, and there are ways we can use to be able to counter that. Several ways. It's up to you to choose which works best for you. So I just want that to be clear, because sometimes it might put you off when you're doing your rejexes and you're like, why am I not getting? And maybe you just put a capital instead of a small letter, or the way around. So if I run this, because I want to get the span of my match object. Remember now I changed my match object to small ABC, and I want to get the span, I want to get the string, and I want to get the group. So if I run this, so I get the start and the end. This is the index. This is what the output does without anything, just putting it out. Then this is the group. This is now the pattern that I was looking for. Then the entire string that's printed was this. This is where my pattern is at. Then we have read.compile. So read.compile is just like the English word compile. So what we do is that we first just create the expression that we want to search for. Create it, so like we want to search for an expression ABC. So as we had done earlier here in the search, but now you see when we did with the search, with the ABC, when we did with the search, we wrote the expression inside the function, inside the method search. But if you wanted to reuse this, we couldn't, we'll have to keep on typing ABC, ABC. And sometimes very long regular expressions, which we shall see later. Not just simple 3-letter words. So we can now put this, we compile the ABC and put it in a variable pattern. So this pattern, you can use it and reuse it to do with some other methods like find all. We remember we said all returns all occurrences of the pattern, this pattern ABC, in a list. So for us to make it better for visualizing it, I did a for loop. So if I run this, let me compile it first. Let me run this. Then I can now find all occurrences of ABC. And you see there's so many ABCs, but remember the search just gave us this first one, but find all gives us all occurrences. So what's the difference between find all and find iter? So find iter gives us now all this, but the match objects. So if we do, remember now I said we can use an expression that we compile. So if using this pattern here for find all, we're using the same pattern here in the find it. So if I run it, you see now we get a list of match objects. All of them are ABC, but now we get more information about the expression, and we can use it differently than how we can use the list. Then we have read.sub. So in the read.sub, you remember in my string, I have a sentence here, I love cats. Maybe I change my mind and say I love dogs. So what can I do? Instead of now going back and changing this string, maybe it was it's a long string, I don't feel like going back and changing it, or maybe I or I can't even remember where the sentence was. So what can I do? I just substitute. I say read.sub. This is the pattern I want to be substituted, and this is what I want it replaced with, and then this is a string. Simple. And I run this, and you see now my cat has been changed to I love dogs. So that's how read.sub works. Then here, read.split, it now splits, it like divides this text to search string into segments. So this expression symbolizes a white space, and I will go into that later, why we use \s. This is known as a special, this is a meta character or a special sequence in regular expressions, and there's so many more apart from this. So if I run this, I'll notice now that it has been divided. Everywhere there was white space, like a space or a see here these spaces, or if there was an terminator, like the line ended, stuff like that, those are white spaces. And see now we have commas, which like now segment each of them. So that's how read.split works. So now we go into, here we were just using simple patterns, but there are some characters which are special characters that are interpreted in a special way using the regular expression engine, which is like what really drives the regex functions in Python. These meta characters make it easier for us to do more stuff, like they make it more powerful, and they interpret in special ways. The first one is a \. I believe we have used it not only in regex, I believe we have used other times. And what it does, it escapes the special characters or denotes character classes. So for instance, here I have a dot at period is a special character when it comes to regex, and we shall see how it is. And here if we want to just get the periods themselves, we have to escape it. So if I run this, we see that we have occurrences of a period in this span, these are the period itself, like inside the string, the period itself. But if I remove this backslash, you'll notice what happens, and we'll figure that out, why this happens. You see, have so many things that are now part of our outputs, and we'll find out why. Why is that so? So let's just leave it at how it was. So what does a period do? A period without a backslash now matches any character except the terminators. So a terminator is something that shows the end of a line. So one common one, and one that is mostly used in the backslash n, that indicates a new line. So if it indicates a new line, it means the other line is ending. So that's basically literal explanation of a terminator. So here we want to find all characters except the new line. So when I run this, you see, it gives us all the characters inside my string. So this is now the importance of now using these characters. Sometimes, you just want to find everything, or you need to find everything, so you can do that. And we have a caret. So the caret matches a literal at the start of a string. So, and most of the time we try and say and use it to check if a particular pattern, if the string starts with a particular pattern. So in this case, we want to check, we are looking in our string text to search, and we want to find this pattern. And you remember read.search, what does it do? It returns a match object if this is true. If it is false, it will return a none. So let's hope that it starts with the word this. And it does. So because it tells us, you see, even it indicates a 0, like the first index of the string. But now the thing happens is, even if I remove this T, it doesn't start with his, it started THIS. If I do this, it returns a none. But if I did if I did TH, and because it starts with this, definitely it has to give me something, right? So it matches. So it has to be what is exactly starting. The opposite of this is a $sign. And we have to put, you see this we put at the beginning, but the $sign we put at the end. So it's basically what it does, and it matches whatever pattern is at the end of a string. It can also check if this is what is at the end of a string. So if we run that, it returns like the object, because our string itself, like if we print it out, let's confirm our string ends with end. So good. So now I want us to discuss these three: the question mark, asterisk, and the plus. So these two are related but different, and we need to be very careful when using them. So a question mark matches 0 or 1 occurrence of a pattern to the left of it. So in this case, I have a phrase. I just came up with that phrase just for demonstration purposes. It has no grammatical meaning at all, just for demonstration. So I want to find eta of this pattern PAN, that my pattern is PAN, but now I put a question mark after A. Means what is being highlighted in this case is the letter A, because we said to the left of the question mark. So it has to match either 0 or 1 occurrence. So in this case, we have this has 1 occurrence, this has 2, this has 1 occurrence, this has like many, and then this one has 0 occurrence. This one, 0 occurrence. So if I run that, you see, it just gives us PAN. It gives us where there's 0, but we always have to make sure that it doesn't give us this, because in our pattern, there's no U, PU. You see now there's no U, it is just PN, because now there was 0 occurrence of letter A, yes, but you see it's PUN, so this won't be given, but this will happen because there's P and N, but 0 occurrence of the A. Then when it comes to an asterisk, it matches 0 or more, not just 1, more occurrences of the pattern. In this case, if I run this, you see it matches now the rest, like 2 occurrences, this number of occurrences, and also as well matches where there's no occurrence. That's the asterisk. Then we have a plus. A plus matches 1 or more occurrences. That means it does not match 0 occurrences. It has, like, there has to be an occurrence of that pattern that's to the left, like single character, and more occurrences. So if I run this, so you see we haven't matched the PN because this is 0 occurrence, but the rest, it has matched either 1 or more occurrences of the letter A. Always note, it is the character to the left of either the plus, the question mark, or the asterisk, and we shall see use cases for this. Then we have the curly braces or brackets, however you call them. So this, they match a specific number of occurrences, like the exact number of occurrences. So for instance, I have a pattern, and we shall see why I've put this in brackets, because I want to group. I don't want a single A, B, C. I want a whole pattern ABC like this. So if I can, let me just print our string. Let me print a string so that we are together. So you see our string here. We have like occurrences of ABC, like this one has 1 occurrence, sorry. ABC has 1 occurrence here, 1 occurrence here, like 3 occurrences of ABC, 5 occurrences of ABC. So I want now from my code here, I want exactly 5 occurrences. So let me find the iteration. I want exactly 5 occurrences. So I look through the entire string and find all cases of exactly 5 ABCs. So if I run this, it's just 1, because it's just this one. Then again, same thing with inside the curly braces, we can add a comma, and what this means, it can match either the N, like N represents this value, or more occurrences. Remember, this was exact without anything, but if I add a comma, it means that number or more. So if I run this, see, it matches like 1 occurrence, 3 occurrences, or 5 occurrences. And then we can also match, we can also now add another value at the end. So it matches at least 2, at most 4. So if I run this, so it just has, we have this 3 and 4. We have left out the 5, we have left out the 1, because we want at least 2 and at most 4. Then we have this OR, and we have used OR a lot. and it just means the same thing. It's the OR operator, either or. And we can, remember I said rejects are are case sensitive. So sometimes you might want the pattern ABCD. So you might want it in capital or in small letters, because if I just wrote the capital, it just gave me the capital. But if I want either the capital or the small letter, I can do this. And you can use it. This is just a simple use case. You can use it in several use cases. So you see, it has given us the ABCD that was small letter and the ABCD that was capital letters. Then this is used to capture like a group of patterns, as you saw here. A by itself is a pattern. I did this. A by itself is a pattern, B by itself is a pattern, and C is a pattern. So I want to group them into one pattern where I'll be able to check now for maybe the value that I wanted here. That's why, and we can also use it as well to group many rejects. Like if we have many rejects, we can also use it to group them together. Then we have and we now when you're grouping rejects, we'll put them in brackets and use the OR operator. The same thing that we have done here. You see we have multiple rejects. Then we have the square brackets, which I shall show you examples. So it matches any character, any single character that is inside this. It acts like an OR, kinda. So any of the characters that are inside the square brackets. Then when we add a character to just before the characters, it does the opposite. So it matches the characters that are not inside the square brackets. So we have discussed the meta characters. So now, in addition to meta characters, we have special sequences. So this make it easier when we're doing our search. Like, you know, we can use them instead of like literally like trying to figure out like how do I represent this. We can use special sequences. So one of it is, and something to note is that I would advise you to use a row string. So a row string, what does a row string do? You see, when we print \n\t line, this means a new line, then a tab, then new line. That's what Python interprets this. But if we now make this string a row string by just adding letter R, and either be capital or small, I prefer using small, it will literally interpret this as \n\t new line. So let's see what that means. So you see what it did here? It created a new line here, then did a tab and new line. But if I made the row string, it just gave me this output. Like it just gave me what I want, what I just typed, like interpreted it literally. And sometimes when you're doing the sequences, you might want this literal interpretation, not the Pythonic interpretation of what you're doing. So I'd advise you to use row strings just to be safe. Then, so one of the sequences and one of the most common ones is SW. Okay, all of these are common. So you have a \W. So this matches alphanumeric characters. Alphanumeric itself, alphabets and numeric characters, and also includes an underscore. So if we find all alphanumeric characters in text search, let's see what that does. So it gives us all the alphanumeric characters, including, remember, I don't know if the \_ underscore was there, I removed it, but if there was a \, it will output the \. We have \d, not \, sorry, underscore. If there was underscore, it would output the underscore, not \. Note. Then we have \d. \d matches all the digits. Now, these are numeric values 0 to 9. So if I run that, just gives me, I only have these values in my string. These are digits. Then remember I did the \s matches white space characters. So let's look at what white space characters are in real sense. So white space characters are these. So this is a space, space, space. If you had a tab, it will do that. A new line is as well. Yeah, I think I just have new lines and white spaces. So and empty space, empty string spaces. So that's what \s does. Then \b matches a boundary for or empty string. Like you see now, this is an empty string boundary. So this is an empty string boundary. So it matches the boundary at the start. So it therefore matches a specified characters that are at the beginning or at the end of our. So like it kind of shows you like if this is an individual word by itself. So because it checks if there's a white space before the word. So for instance, if we were to print, if we were to go back to my string, let me just print it out. For you guys, because I might have forgot how my string looks like. So I want us to look at this. So this LA, there's a white, there's a boundary around this. And then there's also a boundary before this. But now with this one, there's no boundary at all. So if I was to, so this kind of shows that this, like this, the whole word itself has a boundary, like there's this and this. And then with this one, there's a boundary by itself. So there's boundary by itself. So we have a word la and we have a word lala. So it will match the two of them. So if I was to run this, let's say we have two matches and these are the matches, like this is the indexes where the matches are at. But now you see this statement, and please note this, if we write uppercase letters for these sequences, we'll do the opposite. So for instance, we know that the opposite of this is a letter that does not have a boundary, which is this one. So if we do that, let's try and see. If we do a capital B, we see that it now matches 1. Same case, same to the rest. So we said that a small s matches all the white spaces. So if we do a capital S, let me just print some, because I know there will be a lot of them and you won't be able to scroll all the way. Let me just find all. If we do that, white spaces. So it does the opposite. It prints whatever is not white. So it contains everything except white spaces. Then if we also do this, it will print everything that's alphanumeric. So let's see, what is that that's not alphanumeric? It prints out these characters that are not alphanumeric inside. So we see now the importance of case sensitivity when it comes to regular expressions. So now we can try and do a practical example. So I created a file and it has contact, and these are not real contacts, so don't use them or try to create a mailing list from these emails or stuff. So here is my text file called contacts.txt. It contains names of people, phone numbers. Remember, I told you regex are used like to like search for text file. Like you see, this is a very small document, but you might get a really big one. But I want you to kind of look at this. You see, we have names and we have numbers in different formats, and then we have email addresses, and then we have titles. You see, we have the MS here. We have an M. I don't know if that's a title. Then as we scroll down, you see we have professor, we have miss. So we want to retrieve some of the information from this file. Maybe someone wants, so maybe you're working somewhere, then you're told, okay, the first thing you're told, I want all the phone numbers from Kenya in that document. So you'll be like, okay, phone numbers in Kenya. So what's the pattern with phone numbers? I know phone numbers in Kenya have 254 plus 254 or 07 something. And then some people write plus 254, others just write 254. So we need to implement all that inside a regular expression. So here is the pattern for our regular expression. So when we put these symbols in square brackets, it's similar to us using an escape. So we can put them in square brackets. Then we do a question mark. So this means you can either have 1 or 0 occurrence of the plus. Because remember, we said someone can write plus 254 or just 254. Then the next pattern is 254. Then we need to have digits like numbers 0 to 9, but they need to be exactly 9 digits. You remember the curly braces? Exactly 9 digits. Then we have or. Someone can also do 07 and exactly 8 digits. So, you sit down and think of how that. So this is how the patterns for Kenyan number from. This is my own. You have your own pattern. These are not exact. So these are you can create your own defined regular expressions. This is just what I came up with. You can come up with your own, which is way better than this, depending on the concept that I just mentioned above. So you remember when you're reading a file, remember what Lucy said with open. We are opening this file as F. So F is an alias for this opened file, contacts.txt. My contacts.txt is inside the same folder as my notebook. That's why I did not put a path. So, and then what I want to, now you see where I wrote the string, I do an f.read. So when I do an f.read, this kind of like dumps everything, like all the strings here. Like I want to search all those strings inside the file. So once I do that, I print it out. So let's see if I'll get numbers from Kenya. So I get these numbers and they kind of look like numbers that come from, are used by Kenyans for myself. Then again, someone would be like, oh, I don't want numbers from Kenya. I want to get numbers. I don't want numbers from Kenya. Then you'll be like, okay. So in my file, what I realized is I have several patterns. We have numbers that are separated by a full stop. We have numbers that are start with a code and it's in brackets. And then we have they're separated by hyphens. We have a number here that starts with a +1. So we have different patterns, but they basically represent numbers from the US. So you'd be like, okay, this is now a bit challenging, but it's not really challenging. So long as you know the pattern, it's very easy. So our pattern would be, so the first thing is that, yeah, we have a plus, we can have +1. So this plus can either be there or not. So that's why I added the question mark. And 1 can either be there or not there. That's why I did 1 question mark. The hyphen as well can be there or not there. Then now I use the square brackets to escape this bracket as well. I remember I mentioned we can use the square bracket, anything that's inside it, even if it's a special character, automatically gets escaped. For me, I find it easier using square brackets. You can use the backslash if you wish. So the bracket as well, I see numbers that don't have brackets, so it can be there or not there. And remember, I'm using a question mark. I'm not using the asterisk, because now asterisk means 0 or more, But now I have this it has to be 1 or not, 0 or 1 occurrence, not many occurrence, just 1. Then I now have 3 digits. There must be 3 digits after either of these, like exactly 3 digits. Then now you remember when I said when you put square brackets, you can either have a bracket, a period, or a hyphen. So either of this, and not all, just one. So it looks, if it has either of these. Then after that, we have to have 3 digits as well. Then can either have a period or a hyphen followed by 4 digits. I might be mentioning it, but if you look at the numbers, these are some of the options that we might get. So if I run this, so we get all these numbers might be numbers from the US. So you'll be like, yeah, this kind of numbers from the US. Sometimes you might be like, I don't want the ones with periods. So you just remove the periods inside. Just change up your expression kidogo and have what you want. Then we can also as well, someone says, I want only professors. So what, in my understanding, I'd be like, professor definitely will indicate their title. So here I'll say, I want a professor, but now the pattern should be prof. Okay. But now someone can write prof capital P or single P. Remember square brackets, either this. And ROF is definitely has to be there. But sometimes people put the period or not. So like 1 or 0 currencies. Same to a space. Sometimes someone might forget to put a space after the title, when we're writing stuff, we kind of make these mistakes. So if you can choose to allow for that or not allow for that. That depends on you. Then as well, now we put now A to Z means A, B, C, D, E, A to Z, like literally A to Z, small letters, or A to Z, capital letters. In this case, I use a plus, meaning that this person has to have written a name. Like they can't be like just prof, prof what? They have to have a name. So like it has to be 1 or more occurrences of the alphabet inside my sequence. So when I run this, I get names of professors. If you look inside my text file, you will see these names somewhere inside there if you have the time to look in. But you see now my regex has made it easier for me to just extract them. So the last thing I do is email addresses. So this it borrows a lot from the stuff we've done at the top. So for email addresses, we know that an email address can either have letters, numbers, underscores, or hyphen. If we just go here, we'll see like even the email addresses, people write email addresses differently. Some use numbers, this one has used underscore, So we need to include all that in our regular expression. And definitely you have to have it. So you cannot just do 0 or more currencies. It has to be 1 or more currencies. That's why we use a plus. Then the @ symbol has to be there. Escape it just in case the @ symbol is a special character. Then @ something like Gmail or whatever it is. It can be alphabets, A to Z, capital or small. And sometimes we find these domain names some of them have hyphens. So I included a hyphen as well. And it has to be there. So that's why I did a plus. Then there has to be a period. Remember now I have to escape it. Dot, the Gmail or Yahoo or hotmail.com.edu. Whatever. So it has to be alphabet letter, but I want it to be either at least 2 letters or at most 6 letters. So I have included like something like .co or .africa, domain names that are, I don't know what, high level like .com.edu, like high level domain names, at least 2 to at most 6. So this is my regular expression for getting emails in my text document. So if I run this, I get a list of emails and I can do whatever I need to do with the emails. And that brings it to the end of regular expressions. Thank you. In case you have a question.
Thank you very much, Esther. And anybody having a question for Esther? Okay. That was really well placed, Esther. Very good, detailed. And in case of anybody having any question, please feel free to reach out, let's say on the WhatsApp, or you can inbox me or Esther. Okay, now we are going to go ahead and move on to our next presenter, and that's going to be Joseph Omondi. It's going to be touching on inheritance. Okay.
Thank you, George.
Run with it, Joseph. Okay, thank you.
Yes. I'm sharing my screen. Let me know when you can see it.
Yes. Looking
right. So yes, today I will be touching on inheritance. By the way, my name is Joseph Omondi, as you've heard. So inheritance, we'll be working on inheritance in Python. And inheritance is basically a concept, as the name describes, whereby we build a child class that inherits the methods from a parent class. So a parent class is basically just a class whereby it has methods that are defined in it. And when we talk of inheritance, what happens is when we have another class, the class basically adopts the methods or inherits methods from that specific parent class. So any class can be a parent class in this order, in that there is no specific rule as to what class can be or what class can be a parent class. So any class can be a parent class, any class can inherit from another class. These are the different types of inheritance in relation to Python. So single inheritance is whereby if we have 2 classes, so in this case, class A and B, class B will inherit from A. So it will inherit, it can be one method, it could be multiple methods, but in this case, it's only one class inheriting from another class. In the second one, the multiple inheritance. So in multiple, as the name states, it's pretty much multiple classes inheriting methods from a single class. So in this case, we'll only have one parent class and we have 2 child classes. So we have class A and B being our child classes in this case. And then in the third case, we have the hybrid inheritance. So in hybrid, this is where the concept of any class being able to be a parent class comes into play as well. It does explain it better, because here, as we can see, we have A, we have a class A, and we have a class D. So these 2 here, they're inheriting, sorry, class B and class C are inheriting from class A as well as class D. So in this case, we have class D working as, class D and class A are working as the parent classes, while class B and class C also working as the child classes. Then on the next order, we have hierarchical inheritance. So hierarchical is whereby we have one single class or as a parent class. Then we have multiple other classes working as operating as the child classes. So in this case, we have class A being the parent class, and then we have class B, C, and D being the child classes. So they're inheriting the methods from class A. And then the last type of inheritance that we have in Python is the multi-level inheritance, whereby if we have multiple classes, so it will be one class inherits from one, then a new class inherits from the child class. So that in that case, the child class becomes the parent class. Then if we have another one, it inherits from the child class now, and then the child class becomes the parent class. So pretty much that explains the whole concept of any class being able to be called a parent class, in that any class can be able to inherit the methods from any class as long as it has methods defined in it. So we can do this in a presentation type of way. So let's see here. Let's go to PyCharm. So here we have a method, a predefined class. So I have a class here. I have a class here called class vehicle. So in the class vehicle here, we've initialized. So whenever we have a class, we have to initialize the variables. So what we did in here was I went in and initialized the variables. So when you do the init method, which is a special method, you get the self. And then we have, so the variables that are needed to initialize were the name, max speed, mileage, and price. So basically these are just variables that I thought of, okay, when I'm defining a vehicle, what attributes would I want to give it? So the first one is the name, the next one will be the speed, the mileage of the car, how many miles the car has, and then the price of the car. And then I defined another class, I defined another function here, just to give a description or to print out the whole description of everything once it's actually compiled together. So it will be in the form of, I instantiate the description and give it if you see this here, I have a wildcard here. So this what happens with the wildcard is anything that's defined here as the self.name is what will go into the first wildcard, and so on and so on. So we have 1, 2, 3, 4 wildcards. So we have 4 wildcards and we have 4 attributes in here. So if we did not have a match, then we'll get an error in that it will tell us that we needed to have at least the equal number of matching characters as well as we have in wildcards. So once we have those functions defined, come down here and instantiate a new car. So in this case, I just went to the model X. So model X, we equate that to vehicle, and we will do. So we have here. So if you see here, we have 4 values, right? So we have 4 values. So we'll do model X vehicle. Then we run this. So if we run this vehicle, so basically we're missing required arguments. So we need to add 2 arguments for. So the first argument has to be for name. Second argument has to be speed. Third one, mileage, and the last one is price. So here we can do name. Let's do Toyota. So name is a string, so you have to make sure that you put it under quotes. And then the max speed, it's an integer, it's a type integer. And then that's the mileage. And then the price is an integer as well, or a float. So we can just do 4,000. And then we can print. So here, we can print the model X dot description. So if we print that, yes. So if we print that, now we see that we are able to actually print out the statement here. So as the description here states, this wildcard here, the wildcard here is replaced by the name, so the self.name. So that's what we have here. So Toyota has a maximum speed of that, and it also has 18 miles and retails for this price. So that covers the whole creation of a class, as well as being able to define what you want to as the output. So now in regards to inheritance, we will have to create another class, of which we have a new child class down here. So let me uncomment that. So we have a child class here. So the new child class is the class models. So we're basically building a brand new class, and then we have the class models. And in parentheses, we have the vehicle. We added vehicle. So in this case here, vehicle is the parent class, models is the child class. So since we are inheriting from the vehicle class, we have to ensure that we add it on there to let it know, okay, what class we are trying to pull data from. So then we do the initialization as well. We do the initialization as well in this class. So we create the function to initialize that. So we have the same attributes as the ones that we have up here. We have self, name, max speed, mileage, price. The only new attribute that we added in this class is the color. So color is a new attribute that has been added into the model vehicle class. For us to be able to use these instantiated values up in the vehicle class, we have to call the super method. So what the super method does is it lets us use these values in here so that we don't need to redefine them again in the child class. So we do the super method, braces, and then initialize. We have name, max speed, mileage, and price. So these are the only values that we are using up from this side from the vehicle class. So we don't need to redefine them down here again. So that's why we we are only instantiating the self.color, which equals to color, Then since here we are doing since here we added a new variable, which is the color, we need to add a new description as well. And what happens with the new description? So we have a description on here, and we also have a description on here. So what happens is whenever we are running this class, any method we add to it, if the same method exists in the parent class, it will get overridden by the method that we have in the child class. So anything in the child class overrides what we in the parent class. So in here, we have a description that prints 4 values. So we have name, speed, mileage, and price, but we needed to add a new one as well that would have printed the color. So we add that there, and then we can instantiate that here. So if we run this, if we were to run this method here, so what happens is we have new instances of a car. So we have which is vehicle. We give it the vehicle object, and then the car is a Toyota. The max speed is 200, 100 for mileage, and then the price is that. So let's comment this out. So basically now we are in the child class, so we are running the program for the child class. So here, if we run this project again, it will print the 2 values. So the 2 new objects that we've associated in there. So basically, it has inherited all the functions of the parent class. So this is just from the types, this is more of what's called inheritance. So it's just one class inheriting from another class. So the same can be done for multiple classes or for multiple child classes, depending on what you want to inherit from the different classes. So that somehow does handle the whole topic of inheritance. And the next one we'll be going to is operator overloading in Python. And operators basically are just, if we can remember correctly, operators are pretty much variables. So they allow us to perform operations on values and variables. So like the plus sign, greater than sign, symbol, the greater than or equal to symbol. Those are what we call operators. And we can use those. So we do operator overloading by actually creating or instantiating a new method within the same class for us to be able to handle the whole operation of, let's say, addition, subtraction, or something like that. Let's see here. Okay, so we have different types of operators. So arithmetic operators, if we look at arithmetic operators, which are the ones that are used with numeric values to perform common math operations. So that's the plus, minus, multiplication, division, modulus, and so on. And then we have assignment operators. So assignment operators, which are just used to assign values to variables. So if you wanted to initiate an X, but wanted to give it a value, you will say X equals 5. Or if you wanted to do X equal X plus or minus 3, or X equals 3 plus, X equals X plus 3. Now we'll go with the next values, which is X plus equals 3, and so on and so on. So basically all we're doing is just we are instantiating, or we are assigning our operators values to variables. The next types of operators, we have the comparison operators, and these are basically just used to compare two values. So you can compare whether they are equal, you can compare whether they are not equal, whether one is greater than the other or less than the other, or whether one is less than or equal to the other. Then we have logical operators, which are pretty much operators that are used to combine conditional statements. So conditional statements are statements that we use to try to get some information. So we can say, okay, let's check if something is greater than 2, for example. So we can check if something is greater than 2, and we can use the AND statement to add another condition on there to check whether the value is also greater than or less than a certain amount. So in this case, like the first case, it will be X is less than 5, X is less than 5, and it's also less than 10. So we're looking for a value that's between 5 and 10. And then in the second case, it's the OR statement, it's the OR operator, which is checking whether X is less than 5 or it's less than 4. So it's more so just combining the two conditional statements. And then the next set of types of operators, we have the identity operators, which basically identifies whether one value is actually another value. So we're just checking. So it's not necessarily, it's different from, see the one here. So these are different from if you see the assignment operator. So assignment operator, the equal sign here is a single equal sign. But if we go here, to the comparison operators, we have the double equal. So those are two different values. So one assigns value to a variable, and then this one checks whether the two values are equal. So that's the difference between those two. And then the second one checks whether the values are equal or not. Third one is greater than, less than, and so on and so forth. And then the next one, the logical operators. Sorry, I think I'm back. I went back, yes. Okay, yes, I'm here. So the identity operators checks if one value is the other value. And then you can also check if one value is not the other value. So basically it's just like a condition where you're checking like, okay, is A B or is B A? So we're trying to just check that. And then in next one is the membership operators, which are used to test if a sequence is present in an object. So a sequence could be, we can look through a statement, or we can look through a string to check whether a certain character is in that statement. So we can say, okay, if X is in Y, or if X is in string, defined string, and print something. So it's mostly we'll use in a conditional statement like that. So checking to see whether like, okay, do we have a certain value in a certain variable, or is it not there, or does it not exist at all? And then the last type of operators that we have here are the bitwise operators, which are used to compare binary numbers. I believe we had the last class, we had someone that talked about bitwise operators. And in that case, like if you're trying to check binary numbers, you will come and use these bit operators in that. So to put this in application, we can go here, okay. So I have another class here as well. So let me do one thing real quick. Comment this out. So, okay, so I've defined a class. So I've created a class here. So it's a class operations and did the initialization as well. So we have value here as A, and then we have the self.a. So in here, if we are to do, let's say we wanted to do add. For us to be able to add these two values, our class objects do not recognize what the plus sign means. So we actually have to go in there and insert the whole add function. So which is what I added on here. So in this case, if you do the add function, we have to do the self, and then the next one will be the other. So what we're trying to do is the other will be, in this case, will be the next value that we're trying to add to it. So the self, which is self.a, and then the I is other.a. So we're using the same variable. So in here we have a number. So down here I instantiated a number object. So the number object equals to operations. So we can do operations equals 8. Then instantiated number 2, which is equal to 4. So if we don't have this method here, and then we tried to attempt, let's say, print the sum. Let's do print sum. So we're trying to add these two numbers here, the two numbers, so the two objects. So if we run this, we get an error. So it's an unsupported operand. So object classes or objects do not necessarily recognize what the plus sign means. So we have to add the function in here, the add function in here, for us to be able to actually use that plus sign, because this add function is only, this add method is only available in int class. So once we do that now, so this is actually the concept of operator overloading. So we are all overloading this operator here and this plus operator with that method, such that now if we run it, it will give us now the answer here. So the answer now is 8 plus 12, which is 12, 8 plus 4, which gives us 12. The same can be done for multiple other functions as well. So in this case, we have the greater than. So we can check if 8 is greater than 4 or not. So I created I have the greater than function here. So what I did is if A is greater than other A, return true, return false. So we are checking if the first number is greater than the second number. So if we run this here, this is true, which is correct. So if we were to change this value here to, let's say, a 1, we should get false. That's what is expected. So basically we are loading the greater than operator with the method. So with this function here. So the function, we are adding the greater than special addenda method here for us to be able to overload that operator. Then the last one here that we have is multiplication. So the concept stays the same. So we're just returning the self A times the other A. And this should be the same as well. So if we run this, it should be 1 times 4, which is 4. And that's the concept of our operator overloading. So basically what we're trying to achieve is actually, we're trying to load this operator down here to be able to get the actual result of what we expect. Because if we don't have this method, instantiated in this class, then we will not be able to get the correct answers. So it will give us unsupported operand type, so the type error, since objects do not necessarily recognize what operators are or what operators do. So we have to actually load that operator for us to be able to achieve the end result of what we're trying to do. So I believe that's it, and I'll open it up for questions.
Thanks, Joseph. Thank you. That was good.
Thank you.
Any question, please? Feel free to ask, or if for some reason you don't have time to ask now, but you can always inbox. Also, you can use the WhatsApp, and you can also use the chat room here. Idris has a question. Is there operator overloading for division? Yeah, we can look that up. I think we should have that. Let me see. I believe we probably have operator. So one thing you have to know that operator overloading is basically means giving extended meaning beyond their preferred operations. So for example, a plus can be used for concat. So to do it like in in Python, overloading is achieved by overloading the method which is specifically for that operator. In the user-defined function, for example, add, like underscore, the word add, underscore, and then open bracket self, comma, X is a method reserved for overloading a plus operator. And we can do underscore, EQ, underscore, the same. We can do that for equal, which is a comparison operator. So let me see. Python division. All right. For division, so we can operate overloading. We can use this to customize. So we can use a plus sign, the multiplication, the less than, and all that. So yes, to answer your question, you can actually do that just by customizing it. Okay, like we do underscore, add, underscore, and then we do self X. We can do underscore, EQ for equal sign. So we use equal. We can do underscore, MUL, underscore, that's going to be for multiplication. We can do underscore, DIV, and these are almost what you would talk of as the user-defined functions, but you're basically doing operator overloading. So it's possible it can be done, and I'll send you some examples in the chat. All right. Any other question? Anybody? Okay. If we don't have any other question, I know this is a very long session, but we're almost there. So we are going to go ahead and open the session for Ibrea. Ibrea, go ahead, please. Run away with it. Okay.
Hello. Okay. Thank you. I hope everyone can hear me. So
yes, we can hear you. Just a little bit louder, though. Make it a little louder.
All right. So I will be taking you through polymorphism. Polymorphism is one of the very most important features in object-oriented programming. So to start with, I will be going to
you probably want to do the slideshow so we can see.
Oh, sorry.
Yeah. Thank you.
Is it okay now?
Not yet. Yeah, it's good now.
Yeah, all right. So let me start with the definition of polymorphism, maybe for someone who will not understand or not come across the word. Polymorphism, the word, it is a joining of two words, poly and morphism. So poly means many and morphs means form. So it means many forms. And one of the real life examples of polymorphism is maybe when we have a person who can have different characteristics. So one person in a particular situation can be a father in another situation, you can be a student in another situation, or even you can be a husband or something in another situation. So in this case, we're having one person exhibiting different characteristics according to the situation that this person is in. So, and if we bring this to the Python concept, we can still have now one particular object or class or something that takes in different behavior in different situations. And we will be going through that as I'll be. So for one, polymorphism in this case, and we'll be going to illustrate before I illustrate, by definition, it allows us to perform a single action in different ways. Maybe you want to you define an interface in oriented case, and then you can use this one particular interface to give out different output depending on the operations that you will be performing this interface. So let me first start with polymorphism in addition operator. In this case, I think this is the simplest occurrence of polymorphism that you can maybe explain to using a layman, to someone maybe who is not in the field of IT or programming or so. So with the addition operator, it's like what the concept that John explained, the addition operator can be used to give different outputs. For instance, in integers, we can use an addition operator to add two integers and give the result, or maybe when we have 1 and then 3. So when you use the addition operator to give 1 plus 2 is equals to 3. And at the same time, the same operator, if we use it in string data types, we can use to add two strings. We can concatenate two strings. For instance, maybe when we have Ibrahim and then Koso, we can join the two strings, and then we have Ibrahim Koso keyword joined. So, and that is also another way an addition operator can be used. So here are the examples here. So in this case, we are having an integer data types, and in the second scenario, we are having a string data type, of which each of these two cases, they give us different results. In this case, we sum up, and in this case, we join two words. So we have seen that a single operator has been used to carry out different operations for different data types, and that is the most simple occurrence of polymorphism. And then another occurrence of polymorphism is when we have this concept exhibited in within a function. And one of the most basic function, common function that we have give us different results in different situations is the len function. So the len function, the purpose of this len function, it gives us the length of a particular data type. So in a case we pass a string as our data type, then the len function can iterate through each and every character in the string and give us the number of characters in that particular string. And then the same len function, in case we give maybe in a variable here, maybe a length of something like this. This is a list of items. So in this case, it won't go through from P to Y to T to H, but it considers that this is a list element. So it goes through each and every element and give us 3 for this case. So the same applies for dictionaries, the same applies for tuples and so on. So this, and remember, len function is a built-in function. So yeah, so a polymorphism can be, len function is a polymorphic function that gives us different results depending on the data type we feed in. So, and this is the most important part about polymorphism. Here I will be discussing polymorphism in object-oriented programming. So in object-oriented programming in Python, it means that a particular object belonging to a particular class can be used in the same way as if it were a different object belonging to a different class. So for instance, maybe when we have an instance of, we create an instance method, one instance method can be used to give an output for 2, 3 different classes, depending on the objects that we pass in. And we will be going to have this illustrated in the next part. Yeah. So in this case, this is polymorphism in class methods. Okay, first and foremost, maybe let me give you let's recap on what is object-oriented programming. In object-oriented programming, the concept is modeled as either class or object, where an idea is defined using the class, and then the instance of that class, we call it objects. So literally everything that we do, it revolves around a class, an instance, or an object. And by the almost, I think you know almost everything in Python, actually almost everything, yeah, it's objects. Because a list is an object, a dictionary is an object, string, integers, all these data types are objects. And for instance, maybe when you create a list of objects, the Python interpreter knows that the objects, these are the instances of the list class. So for every list item you create, it's interpreted that is an object of a list class. Yeah, so to go through the code part, in my case, I have 2 classes. I have a cat class, and then here I have a dog class. And in Python allows us to have the same name for different methods in different classes. So and both the 2 classes, my classes, it has 3 methods. The name of all the methods are the same. So first here, I have a cat, and then I hope you know the class. When you define initialize a class, it will start with a capital letter from the Python naming convention. So, and then the first thing you see here is as a class attribute. So this class attribute owner is equals to Brian. So why I passed this one here is that maybe Brian has a number of cats. So for every objects, instance that pass for the class cat, we know that this cat belongs to Brian. We don't really need to repeat the owner, the class attribute. That's why I passed before the constructor. And the second part here is the constructor. So here we initialize the attributes of our class inside the constructor. So, and the first item of our method, class method, is called the instance method. And in our case, it is the self. And by the instance self is what we will use to access attributes of a class every time we want to access the cat class. So, and in the first case, name and the age are the attributes of my class. And then self.name, self.age, this is where the instance attribute is passed now. So whenever you want to access the name, the age, you use the self.name. This is an instance that we use to access the attributes using the dot notation. And then the second method is info, whereby this is the output, and then this is the last method. So here, the same applies for the dog class. I have the same method defined for both the 2 classes. Now, here is now where the concept of polymorphism will come in. Both the dog and the cat class have methods with the same name. But however, the implementation of these methods differ for each class. Because like, for instance, when you look at here, the dog class has 3 attributes, 3 parameters, unlike my cat class here, where I only have 2 of them. And then my second method also, the output for this and the output for the info method in dog class are different. So here, when I come now to instantiate these classes, this is where you give the objects, you create the object for each class. So for the first object, the cat one, maybe you can be having multiple cats, cat 2, 3 cats, 4 cats, 5 cats, and each of them may be having different features or different attributes. So that is why in object-oriented, we say an object stands over a class. One particular class, like a cat class, can be having a multiple objects. The same applies to dog. So that is what the concept of object-oriented programming is. So here I created the instance of my class by saying cat1 is equals to cat, and then I passed in the parameters for my constructor method. And my parameter here is 2, the name and the name and the age. So to create a new instance of a class, we will call the name of the class as if it were a function. So and then we allocate this variable. This is what we call object, and this whole is what we say creating an instance of a class. The same applies now. You can be having cat2, cat3, cat4, but in my case, I just created 2 instances of for both the classes. And then the second one is the dog one. So this is the object for the dog class, and my dog class has 3 attributes: the name, the age, and the breed. And that's the same thing I did. So the concept of polymorphism comes in here with the class. Now, when I want to access the output for each and every method in my 2 classes, this is what I did. So I said for animal in cat1 and dog1, whereby cat1 and dog1 are objects that belongs to 2 different classes. So I said animal.makeSound, whereby a makeSound is one of the method it's actually the method in both the 2 classes. But remember, as much as the name of this method is the same, for each and every class, this method has different output. So I used the name variable here to iterate through 2 different objects that belongs to different class. So instead of having the calling of these methods separately, maybe I call a method for the dog class and the cat class. So I'll be able to do it using the concept of polymorphism here, whereby an animal is, you use a loop, a for loop, to iterate through both the cat and the dog objects. And then these are the output. So when we run this method, this is what I get. So animal.makeSound for the dog class, for the cat class, this is the output it gives me, and the same for the dog class. So this shows that Python is using this method in a way that it gives 2 different outputs depending on the data types that we pass. And my data type in this case is cat1. My object in this case is cat1 and dog1. So this is using the methods in a polymorphic way. So that is where the concept of polymorphism comes in. One particular method can give different outputs depending on what part on the object that you pass. And then the second part here is use of polymorphism with functions. So outside my 2 classes, I defined a new function called poly with the instance pet. So using the instance pet, I will be able to call the method in my classes. As I said earlier, all the methods in my 2 classes are the same. So this is what I do. So using the instance pet, I'll be able to call makeSound method, info method, and makeSound method. I just want this to repeat, so that's why I had this way. So, and for the instance pet, for the instance pet, I'll pass the object for my cat class and the object for my dog class as the argument for this. So this is one function that goes through two classes with the same methods to give the same to give respective output depending on how you have defined your methods, on what your method should do. So, and this is also just use of one class function to give you the output. So when we run this one, this is the same output we get again. So polymorphism in this case, it helps us to use just one method or one function to give an output for different classes depending on the objects that you pass. So maybe even if I'll be having cat2, cat3, cat4, it doesn't need me to call to create this instance so that I'll be giving an output for my class. I just pass in the object or the instance of that class, and then I'll get the attributes of my class. Yeah. So I think maybe the difference between a polymorphism and operator overloading, from my understanding, is that from what we saw this thing working and giving us the output that's giving us, using an operator, polymorphism, it is use of operators or functions or even methods in different ways depending on what they're working on, depending on the objects that we give. So it goes well beyond operator only. But in the case of the operator overloading, it's when you give an existing operators like class, like is equals to a capability to operate on a new data type. That is what we call overloading. So an operator overloading is some kind of a polymorphism. It's just that an polymorphism goes well beyond operators to functions, to methods, and creating an instances that gives different output depending on the object. So from my understanding, an operator overloading is a kind of polymorphism. Yeah. So I don't know if I've made this clear, but you can ask questions.
Okay, anybody, any question for Hebrea in relation to polymorphism? Okay. Just remember, if you have any question and you need to ask, we still have the WhatsApp forum. You just post it there and we'll be able to get an answer for you. Okay, thank you very much, Hebrea, for that wonderful presentation. Now I'll go straight to none other than Monica Njaga to be able to help us with the abstraction and also encapsulation. Okay, go ahead and take it, Monica. Run with it.
All right. Hi, everyone. Thank you so much for the opportunity, George, and thank you so much, everyone, for hanging in there with us. Again, as you heard, my name is Monica, and being the last presenter, I will make this short and sweet and to the point. So we are talking about encapsulation and abstraction. I'll start with encapsulation. It's one of the other concepts of object-oriented programming. So I started with a picture here, and I believe everyone here has probably used a capsule, the drug, or seen somebody use one. And as you know, in the capsule, they put the drug or the powder in there, and then they cover it with this red and white, and they're always colorful, by the way. I've seen some plain ones, but most of them are colorful. So that is the same concept we have with object-oriented programming encapsulation. You hide your methods and variables inside a shell for protection and access only when needed, and restriction when not needed, or when you don't want people to accidentally change your code or variables and methods, then you encapsulate them. So I'll move on to the next slide just so we can see what encapsulation is, and it refers to the wrapping up of data under a single unit. And then in object-oriented Python program, you can restrict access to methods and variables. And why do we do this? This can prevent the data from being modified by accident. And this is what is known as encapsulation. Simply put, encapsulation is the process of wrapping the data and code that operate on the data into a single entity. So you can assume that it is a protective wrapper that stops random access of code defined outside that wrapper. So on to the next slide, we are going to also look at like some of the benefits of encapsulation. You do this for data hiding, and then it comes with a lot of flexibility, because if you want to ever revisit, you can go in and take your code, and then there is also the reusability, as we have known, or as we have seen even from the presentations from Joe and Ibrahim. We can go and reuse this, like anything like classes to create subclasses and on. So there is all these benefits that come with that. Now you may be wondering, so how exactly do we encapsulate? So there are two methods that we use in encapsulation. And what you have seen so far, like whenever Joe was dying, or even Ibrahim, when he was creating the variables or the class variables, the ones that start with self dot, like I guess dog or cat, he did not put, he just put the name. But when we encapsulate, we either use a double score or a single underscore, all right? Now, the single underscore is called a protection method. Well, whenever we use the double underscore, we say that we are privatizing our methods and our variables. So just a brief or summary, plain attributes are achieved in order to achieve encapsulation. Now, before I go to abstraction, I want to show you exactly how we do encapsulation in a real code. And for the sake of time, I have my code pre-written here. So just remember this picture, remember the capsule. And so I'll walk us through exactly how we create a class. And we've talked about this in previous classes, and Joe and Ibrahim have gone over this. So I'll kind of fly through this. So assuming we define a class car, and then we initialize the self, the windows, anything, we say that a class is a blueprint. So anything that comes with a car, right? And then we also create methods under it. And then what we do, we come and instantiate, like we create an object, and then we give the variables, right? Or we give the arguments, like with the windows, we say that this Toyota comes with 5 windows, it has 4 doors, 5 seats, and the engine type is gasoline or petrol, depending on where you're coming from. Now, just to point out, this is what we call public variables in encapsulation. And why is it? Because as you can see, this is exactly what Ibrahim and Joe have been doing. We have no underscores here. We do not have any double underscores. So if we were to just run this and try and access like Toyota Drive, which is the, what is it called? Which is the method, then it returns exactly what we said, that this car has to be driven. I understand that is the automatic cars. Toyota has not reached there yet. Now, the other thing I wanted us to look at is like, you can just like try and print out Toyota. And what this returns, it tells you that it is at least in the, it's an object within the car class. So this is what it means. Now, further along, I wanted us to also look at this dir function, and I have my reasons for, we'll understand why we are looking at it. So if you see, we have defined these 4 attributes, the class attributes to the class car. Now, if we do a dir, and dir function, I just want to read this, is it returns all the properties and methods of the specified object without the values. So this function will return all properties and methods, even built-in properties, which are default for all objects. So like if we run this Toyota right here, it gives us everything that we can use, the default methods in it, the properties and all that. And then at the very bottom, these are the class variables that we have defined way up here, all right? Now, that is it about the public, because we've already talked about that. So now, to the concept of encapsulating using the protection, which is done with a single underscore. So what I have done here, I have gone in and protected the windows and also protected the seats. And whenever any programmer would know, anytime a programmer sees the underscore before the variable, they know that that is a protected class, and it can only be accessed. Well, it can be accessed in the parent class, but the best practice is to access it in the subclass. And subclass is what Joe just went over. So best practice, access it, and you can change it in the subclass, but you are still, nothing restricts you from accessing it in the parent class. And what do I mean by that? A good example, so this is the same class that we created up there, but now as you can see, the only difference is that we have the underscores, and as we said in our capsule here, we protect our methods and variables. So like I've also protected this capacity, and then I would go through the same process of instantiating. So I'm creating another Toyota object, and if you notice, anytime I create or I do a definition, define a function or a method, I have to call self exactly the way it is. I cannot do just sit. I had to have the underscore because it's protected. So if I was to run this, so I've created Toyota and I've put in my windows, my doors, and my seats and the engine type. So I run this. Now, if I try to run the Toyota capacity, what will happen? It tells me that car object has no attribute capacity. And the reason for this is because, you see, we have already protected this variable. So if you ever wanted to access it, and you would need to do a little tweaking. And before I show you how to fix that, let me go again and run the DIR. Remember now the DIR Toyota here will show us all the protection or anything that is in the protection. So if I run this, what you notice here, see, we have the same attributes that we did, the attributes of, the engine, the drive, the doors, but anything that we have protected is preceded by an underscore, okay? So if we want to access the Toyota capacity, we would need to do an underscore. So when we run that, then it gives me exactly what I had told it to return. And I know it doesn't make any grammatical sense. This was for the purpose of the demo. So it returns the engine type plus the self seat, which I have declared as, or at least I have instantiated as 5. So that is why we are getting this. So as you can see, that proves to us that nobody or Python will not restrict you from accessing your protected variables. The best practice, as I mentioned, is you can access and even override them in your child class. So in this case, what I have done, I've just used the same code up here, as you can see, but now I have created another class called truck, which is a subclass of the parent class car, okay? And as Joe walked us through, so whenever we do the child class, we do the definition in it, and then we add the extra attribute, and we do the super, and then we do the original, and then we do our instantiation of we initialize what has come as an addition to the subclass. So in this case, if I was to run Toyota cars and everything, this would still run because I'm running the superclass and nothing really restricts me from doing that. And then if I wanted to see like the Toyota drive and capacity, and that's why I'm running this here, it still runs for me. So this car has to be driven. Now, what if we wanted to create an object for the truck, all right? Let's say we have a Toyota Tundra. I believe that's a make of a car. So we create a Tundra, and maybe I can put a small t, it doesn't matter, is equals to truck. So now this requires us, as Joe said, it requires us to put an additional attribute, because now to the track, we have an additional attribute here called horsepower, all right? So if I run this and try and access like the Toyota.horsepower, in this case, it would return for me the, it would return for me the 4,500. Now, what this means, I can always go in and I can also access any of the other attributes or the private ones, like the seats. So I can do underscore seats, okay? And if I ever wanted to override the number of seats, right? I can do it here. So I can put 7, let's say, and then if I run this and I wanted to see, sorry. So now if I go in here and I do Chandra dot underscore seats, I now get the new value that I have gone in and replaced. So all that to say, you can go in and change the values or your protected values in your subclass, and that will not interfere with what you have in your parent class. Now, the next thing that we talked about is the privatization. That comes with a double underscore. And as you can see, I've used the same class, and then I've gone in and put the double underscores. And in whenever I'm trying to access any of the classes, I have to also do, or whenever I'm creating a method, I have to do the self underscore engine type plus underscore seat. And this still allows me to go and create an object. But now, one thing that you'll see here, if I try and run the dir Toyota, right? If you scroll to the bottom, all you see here is the classes. I mean, is the methods that I've created under there. What happens to the values or the variables that I've privatized? They will come up here, and as you can see now, they're in a different format. They say underscore car, underscore door, okay? Now, what if we wanted to access any of those? So if I wanted to see how many seats are in a Toyota, so if I went in here and tried to access it using Toyota underscore seats, because that's exactly how it is. Guess what? It tells me that car object has no attribute underscore seat. And the reason or the way we access that is there are two ways. So we can either use name mangling, or what we call the getters and the setters. And what is name mangling? So if you want to access the seats, you have to write it exactly the way it is, okay? You have to reference the parent class or the class. So if I was to replace this with underscore car underscore seats, then I get my value of 5, all right? And that's the same case if you wanted to access the capacity. Now, as I mentioned, there is 2 ways to access the private variables. And when you look around, they actually say that privatization is not that common in Python, but it still exists. So if you are ever in a place where you needed to do that, then you know exactly how to go and access your values. So it would be the first option of name mangling. And then there is the access via getters and setters. And what does this mean? So with the getters and setters, you have to go and create a different method, a method called the set, like set whatever you have privatized. Like here, I have myself dot underscore tech as Python. But if I want to access it, then I have to use a set method and a get method with the name of this attribute or the variable. So with this, so if I wanted to go and create an object for this Embrace IT, by the way, Embrace IT is the name of this school, for those who don't know. So Embrace, you do object Embrace IT. And then if I tried to access the get tech from here, because I've already put the, or I've already gone ahead and initialized. So let me grade this out first and see how we access the, method, the first method, which is bootcamp, which tells us the machine learning or the course and whatever tech that is. Now, if I wanted to go and change my tech from Python to something like Seaborn, right? I need to go in and first set it, because I have to set it to a different value and then you get it, okay? So if I run this now, the set, and then I get it, you're gonna see something different. So now it goes to machine learning, and then it says Seaborn, because Seaborn is the value that I have set. And whenever you are setting, you have to call the self and then the value that you're gonna give the new value that you're setting, because setting is like updating to a new value. So with that, I have covered the encapsulation, which happens by the underscore, single underscore for protection, and then double underscore for privatization, and how to access using the name angling, and how to access using the getters and setters. You can go more into the documentation that's online and you will see a lot more of that. So with that, I will go back and cover the abstraction part of object-oriented programming. And as the name suggests, so when you have an abstract, you have an idea, but you don't really have a design. So you create something very sketchy that you revisit later and put in the design. So onto my next screen, we're gonna define what abstraction is. So abstraction is an object-oriented programming concept that focuses on relevant data of an object, okay? You only show the relevant data. It hides the detail, the background details, and emphasizes the essential data points for reducing the complexity and increase efficiency. And then it retains only information which is relevant for that specific process. And we are saying that it mainly focuses on the idea instead of the actual functioning. So remember, it's an abstract, it's only an idea. We don't know all the details of what's going to happen after that. Now, on to my next slide, and this is one that I would like you to pay special attention. Some critical components that make an abstract class. So abstract classes are classes that contain one or more abstract methods. So an abstract class has to contain a method. Now, in that method, so point number 2, an abstract method is a method that is declared but contains no implementation. And what do I mean by that? So like in all the things that we have seen, or all the methods that we have seen, we have either told it return cat says meow, or the dog barks, or return A plus B. But for the abstract method, you do not return anything. It's just an idea. It has no design to it or no implementation. And then an abstract class cannot be instantiated and requires subclasses to provide implementation for the abstract method. So now abstraction kind of borrows from inheritance, because this is the concept of inheritance is where you create the subclasses. And then subclasses of an abstract class in Python are not required to implement abstract method of the parent class. Now, on to the next slide. Why do we need abstraction? So it helps you simplify the presentation of domain models. It hides relevant details found in the code, and it helps partition program into many independent concepts, and also offers great flexibility using abstract data type objects in different situations. So what I have here is an idea of exactly what we are talking about. So if you are sent out to do a survey, or at least get information for people who want to open a bank account, right? Most likely you are going to get the form that you're given, because it's a random form. It would have you filling all this information. But guess what? To open a bank account, we don't really need to know your favorite food, movie, or actor, right? So this is the only information we need: your name, full name, address, contact number, and tax information. So on to the left. So since we have removed the selected customer information from a large pool, the process is called abstraction. However, the same information, once extracted, can be used for a wide range of applications. So for instance, when we have this, we have it in our system, but we're just hiding it because we only need the 4 which are relevant to a bank account application. So for instance, we use the same data for hospital application, job portal application, or a government database, etc., with little or no modification. Hence, it becomes our master data. So this is an advantage of abstraction. So we have all these. Should we ever need to use it in a hospital? At least whenever you go to a hospital, we need to know your favorite foods. So at least you need, or we don't want to know if you have any allergies, then that is information. But we don't need all this displayed when we are opening a bank account. Now, before I go to this slide, I want to go into the code and show you exactly what we do in abstraction. Oops, sorry. So abstraction, as we said, it's only an idea, no implementation. So the first code here, it tells us, so first thing that you always have to remember, you have to go in the library ABC and you have to import these 2 methods, ABC, capital ABC, and abstract method. All right. Now, when creating your abstract class, what tells it that it's an abstract class? You create your class A, or if you are creating class vehicle or class car, but then you would have to put ABC as the parameter. Remember, all the other classes that we have created before, even when we were doing our encapsulation, it didn't come with any brackets after the class name. But this one, it does come with the ABC in parentheses and then the colon. Now, since any programmer who sees that ABC or sees this ABC would know this is an abstract class, then how do we know that it's an abstract method? Anything under it, how do we know it's an abstract method? So how do you declare an abstract method? You use what we call decorators, and then you would put this entire string at abstract method. So in this case, we are saying define display self. And remember, we said an abstract method has no implementation, okay? To implement, you have to create a subclass. So in this example, I have gone and created a subclass called B, and I have, of course, called the parent A, and this is where the inheritance and abstraction kind of go together. And then this is where I'm going to implement my abstract class, abstract method that I defined in my line 8, and then say, you print, this is a display method. Now, remember, in our slide up here, we said that abstract classes contain one or more methods, and then abstract methods cannot contain any implementation. But we also know what told that abstract classes cannot be instantiated. They at least need a subclass to provide implementation for the abstract method. And what does that mean? So if I go back to my code here, so we know A is our abstract method. So, and we know we cannot instantiate it, but let us just try, because seeing is believing. So if I try to create an object for this abstract method, which is A, and at least also like call our method in it, let's see what happens. We get an error that you cannot instantiate an abstract class A with abstract methods display. So that proves the same point that we went here, that you cannot instantiate an abstract class. So what do we do if we want to instantiate or at least implement the abstract class? As the notes also told us, so we have to go and do all that in our subclass. And let me just make this a little smaller. So we have to do that in our subclass. So in this case, our subclass is the B. So I'll just go in here and do the implementation. So I will create my object 2, call it that. So now if I was to run this, so here it is. It does implement, or at least it gives us what we need here. So point to note, you cannot instantiate an abstract class. You have to create a subclass to do your instantiation. Now, our second example here talks about, we have animal class, and this is like the hierarchical or one of the inheritances that Joe talked about, and I'll share this so I don't really need to go to it. Now, I need to talk about this point because we said, so, or this is a good fact to know. So in case where the abstract class has more than one method, all the abstract methods must be implemented at the subclass for an object to be created from the subclass. If only one of the many abstract methods are implemented, the subclass is still considered as an abstract class, hence no instantiation is allowed. But how do you resolve this? Number one, you would either have to implement both methods or as many methods as you have in your parent class, or create yet another subclass and now use the second subclass to implement your second method. So this is, let's do this practically. Remember, point number one, you have to import the library ABC and then ABC and abstract method. So I have class house and I have two abstract methods here. And remember, whenever you have as many as you have to write this decorator before each one of them, all right? So we have abstract method one, which is H1 and then H2. Now, if we go in and create a subclass house, okay, I mean range as the subclass of the house, and only implement one of the methods, what is gonna happen? We saw in our notes that you have to implement both. If not, it will still perceive this as a subclass. So let's see what happens here when we try to instantiate the range, okay, with only one, the two methods implemented. So we run that. So guess what? It says we can instantiate abstract class range with abstract methods H2 because it is deeming this as an abstract class. The reason being you have only implemented one of the two methods that you had in your abstract class. So how do we resolve that? As we said, what we do to resolve that, we can create yet another class. In this case, I created another kind of house type, which is called range. So now I will comment this out. So if I try to run this, so now see what I did. So our range class, we have implemented H1, which is what has been defined in rows 16 and 17. And then in my country class, which is a subclass of range, okay, this is now the other two levels that Joe talked about, I have gone in and now implemented the H2, okay? So now I'm allowed to do the instantiation here. And let me just run this code, okay? So you see when I do my object and call country, the house or the class, then it allows me to go in and call my H1 and H2. And as you can see, my H1 says this is a one floor house, which is a range. And the country one, it's a country house. So that's how we get this. Now, what I'm talking about here is the same concept, only that we are using the constructor, what we are used to saying, like the init constructor, and then we initialize. So same thing, you have to declare it as a abstract method. Abstract method for the class has to also be declared ABC, so we can know it's an abstract method. So here, as we saw, we have to implement it at the subclass. So I've created another result, another class called result that calculates, it's either adds the self value plus 50 or subtracts. So now, assuming we wanted to do a proof of concept here, right? And try to prove ourselves wrong. We already did that in the previous slide, but we'll do it again. So we know that we cannot go ahead and instantiate the abstract class. So let's just try. Our abstract class is the calculate. So guess what? It tells us that it can't instantiate. So what we need to do, we need to instantiate a subclass. And that is what we are doing here. I'm sorry, my stuff is just going crazy. I think the more I do it, the more it's getting bigger. So when we run this code, so we get our values. So we have 120 that you add 5, it becomes 170, you subtract 5, it's 115. So that is it about abstraction, and main points to note or to remember. Whenever you're going to call an abstract class or use an abstract class, you have to import this from ABC, import ABC, an abstract method. And how do we mark as a class as an abstract class? It has to have this parameter ABC, and any methods under it have to have these decoders at abstract method. So back to the PowerPoint, and I'm done. This is just a highlight of the differences between abstraction and encapsulation. So abstraction resolves the problem and issue that arise at the design stage. So we said we only have an idea, we don't know what it is, so we resolve that. And then encapsulation solves the problem and issues that arise at the implementation stage. We want to hide our code, we don't want people to manipulate it. Now the focus. Abstraction allows you to focus on what the object does instead of how it does it. Encapsulation enables you to hide your code and data into single units to secure the data from the outside world. How about the implementation? You can use abstraction using interface and abstract class, while you can implement encapsulation using access modifiers, which are the public that we went through, protected and private. And then abstraction focuses mainly on what should be done. Encapsulation is how it should be done. And then application, this is at the design level, and then this is the implementation level. And I've included a link here that you can go and further. And that brings me to the end of my presentation. Do we have any questions?
Questions, anybody, please? Somebody put something in the chat. Okay, so Idris is asking, can you show us the abc.py which was imported? Was that a question for Monica? Is that a question for Monica? Monica, did you import abc.py?
No, the only ABC I've imported is this. And as I mentioned, we use it we call it as a parameter, or we put it in as a parameter so we can, everybody or the program can know that it's an abstract class.
Okay. So this, Idris, that was just an example. But if you were to create a file like a abc.py, you can actually import it as a package. So you can create your own packages. So in this case, Monica was just using an abstract, like just for an example. Okay. Is that correct, Monica?
Correct.
Okay. Idris, did that answer your question? Okay. All right. Anybody else with any question? All right. So if we do not have any question, we're assuming we covered everything and everything looks good. So I just also posted assignment number 10. That's the last assignment, which is going to be very easy because I did almost 80% of the work. So that's good. But again, we thank you all for making it. And we also thank Monica. We thank Esther. We thank Joseph, Ibrea, and Lucy for being gracious enough to help us work on this Zoom session. So without any further ado, I would like to go ahead and just call it a day. I'll post this on the YouTube channel and you'll be able to access and view it. Okay. And thank you again. And, you all have a good night. Okay. Bye.